Let's take a look at inconsistent and dependent equations by matrices on a TI-82 calculator. Now on my website, www.mathheals.com, you can find more YouTube videos, or links to YouTube videos. There's a link here, graphing calculators. I'll probably change that to say graphing calculators / technology eventually. If you click that, then you can go in by subject, and I'm working my way through the subjects. And I'm also working my way through the different models of the calculator. But you'll eventually see all the videos out there for every calculator. And that's every topic that you can that you should use the graphing calculator for in college algebra. There are some that the computer algebra systems will handle, but I'm not going to put those up there. Okay, and then if you just are struggling with college algebra in general, if you go to the top link, Math Class Information, I'll probably eventually rename that as Math Lectures. Then you can go into college algebra, and you can go and watch whatever YouTube video corresponds to the lecture. Now these are the full lectures. These are the same ones I give in the classroom. So they're same example, same explanation. Don't watch a WebEx. I'll eventually remove those. Just watch the YouTube. Okay. Let's take a look at our first problem. And we got 3x plus y plus z is equal to 2. And we got 4x minus 2y minus 5z is equal to 1. And 6x plus 2y plus 2z is equal to 4. Well, let's write down the matrices to go along with this. Now A is going to be the numbers off of our variables. So I'll drop the x, y, and z's and keep the numbers in their signs. So we got 3, 1, 1, 4, negative 2, negative 5, 6, 2, 2. So again, that's just the numbers off of the variable portion here. Okay, now our B will be our constant values on the right side, which will be 2, 1, 4. And how we're going to solve this is we're going to take the inverse of A and we're going to multiply it times B. So let's do that. So go to my matrix, right arrow twice over to edit, do enter on A, and it's asking me for rows by columns. I got 3 rows and 3 columns, so do 3 enter, 3 enter. I'm going to put in 3 enter, 1 enter, 1 enter. And then 4 enter, negative 2 enter, negative 5 enter, 6 enter, 2 enter, 2 enter. I'm going to exit out, do second mode, and I'll go back in my matrix. So press my matrix, right arrow twice over to edit, down arrow to B, press enter on B, and it's rows by columns. So it'll be 3 enter, 1 enter. Then I'll do 2 enter, 1 enter, 4 enter. Exit out, do second mode. Now to do this, I'm going to do matrix, enter on A under names, choose my inverse button, that's x to negative 1, times, now choose matrix, down arrow to B, enter, and enter again. Okay, we get error singular matrix. Now, if you look at well, first let me do the second one, and then we'll compare the results, and we'll talk more about it. So this one, we got x plus y minus 3z is equal to 4. Then 7x minus y plus 2z is equal to negative 1. And then 3x plus 3y minus 9z is equal to 1. Okay, let me double check all those numbers. Yeah, it looks good. Okay, so A, we're going to drop our X, Y, and Z's and keep the numbers in their signs. So we got 1, 1, negative 3, then 7, negative 1, 2, 3, 3, negative 9. And B will be the numbers on the right side, the constants. So I got 4, negative 1, 1. So variable terms and constant terms. Okay, let's enter this in. I'll do a quit on this. And clear. Okay, now I'll go into matrix. Right arrow twice over to edit. Do enter on A. It's a 3 by 3 still, so I can go ahead and do a 3 enter, 3 enter. Then I'll do 1 enter, 1 enter, negative 3 enter, 7 enter, negative 1 enter, 2 enter, 3, 3, negative 9. And let me double check everything. It looks good. Do second mode to exit out. Then go back in my matrix. Right arrow twice over to edit. Down arrow to B. Press enter on it. It's rows by columns, so it's a 3 by 1. So 3 enter, 1 enter. I'll do 4 enter, negative 1 enter, and 1 enter. Exit out. And then I want to take the inverse of A times B again. So do matrix, enter on A. Push my inverse times matrix, and then 2 for B, or you can down arrow to B and press enter, and then press enter. Okay. This is as good as it gets on a TI-82 calculator. Once you get error singular matrix, it means one of two things, and that's what we're going to talk about now. If you look at my first set of equations here, 3x plus y plus z equals 2, 6x plus 2y plus 2z equals 4, I took this first equation and multiplied everything by 2. 3x times 2 gives us 6x, y times 2 gives us 2y, 2 times z is 2z, and 2 times 2 is 4. Now, what this means is this means infinite solutions. It means that you don't have just one answer, but you have an infinite number of answers. Okay, this one down here. Take a look at my first equation and my last equation. Multiply everything in the first equation by 3. 3 times x is 3x, 3 times y is 3y, 3 times negative 3z is negative 9z, but 3 times 4 does not give you 1. This one is a no solution. Now, the infinite solutions is a dependent equation, and the no solution is an inconsistent equation. The problem with the TI-82 is that you cannot tell the difference. It gives you the same error on both of them. So if you get singular matrix, unless you can just spot it like you saw me do it, but usually they're not that easy. I deliberately created these matrices this way so I could get the two possible cases. What you're going to have to do is you just have to do it by hand. Calculator isn't that great on it, but it will tell you that there is a problem, and you know it's going to be one of these two. Now, you can use the calculator to do the REF against this, and then that would help you come up with the actual answer on both of these, actually. Now, if you were to go through and do the REF, you can watch the video on how to do that. What you'd find for infinite solutions is when you get done, your last row is all zeros. And depending upon your instructor, you may go further than just writing infinite solutions. They may want you to write it in a different form, and they'll tell you about that. For this one, if I went through and did REF, I would end up with oops, a little bigger. There it goes. Okay, use your imagination. Let's try it again. Okay. If I did REF, and this is REF on both of these. Now don't get excited. I'm not talking about the REF function. You have to do the REF process. The last row will be all zeros and a single one, and that's what tells you that there's no solution on this one. It'll always be a 1 if you go through and do the REF method. Anyway, You can use a calculator again to tell whether it's a problem area, but that's about as much as you can tell with the TI-82.